Now in this lecture we will find out the radius of the circle. In the drawing we have a circle, and inside this circle we have quadrilateral ABCD. Actually, quadrilateral ABCD is inscribed by this circle, and we also know that side AB of quadrilateral ABCD equals to 3 units. So we will define side AB as A, that is to say AB equals to A, and A will be equal therefore to 3 units. And we will also know that side BC of quadrilateral ABCD equals to 4 units. Therefore we will define side BC as B, and B will be equal to 4 units, and the side CD of quadrilateral ABCD equals to 5 units. Therefore we define the side CD as C, and C will be equal to 5 units because CD equals to 5 units. And we know that AD equals to 6 units, so we will define AD as T, and AD equals to D, so D will be also equal to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. Okay, so first of all I will present to you 3 new rules, and then we will implement the rules in our circle and quadrilateral. So rule number 1 will be that the area of quadrilateral ABCD equals to the area of quadrilateral ABCD that is described by a circle equals to so this is the sign of the area, which means the area of quadrilateral ABCD will be equal to, according to rule number 1, will be equal to the root of S minus A times S minus B times S minus C times S minus D. So here, this formula, A, B, C, and D are the lengths of quadrilateral A, B, C, D sides. AB, side AB equals to A and A equals to 3 units, and S equals to A plus B plus C plus D over 2. Okay, so whenever you have a quadrilateral that it is inscribed by a circle, like in this drawing, then you can calculate the area of that quadrilateral according to this formula. The area of that quadrilateral will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the quadrilateral sides, and S equals to the sum of the sides of quadrilateral ABC sides over 2. Okay, that is rule number 1. And okay, I will actually draw again the quadrilateral ABCD. That could be any quadrilateral. So if we have this circle, and this circle actually blocks quadrilateral ABCD, so quadrilateral ABCD is inscribed by this blue circle, and we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC equals to B units in its size, side CD equals to C units in its size, and side AD equals to D units in its size. Then, according to rule number 1, whenever you have a quadrilateral that it is inscribed by a circle, like in this drawing, the area of that quadrilateral will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. Okay, I'll repeat again. If you have quadrilateral that is inscribed by a circle, like in this drawing, then you can calculate the area of that quadrilateral according to this formula, and S equals to A plus B plus C plus D over 2, that is to say it equals to the sum of the quadrilateral sides over 2. Okay. And we also have rule number 2. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So I'll repeat on rule number 2 again. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and quadrilateral ABCD is inscribed by this circle, side AB of quadrilateral ABCD equals to A units, side BC of quadrilateral ABC equals to B units in its size, side DC equals to C units in its size, and side AD equals to D units in its size, and quadrilateral ABCD has two diagonals. The first diagonal is diagonal BD, and the size of diagonal BD is x units, that is to say BD equals to x units in its size, and we also have the second diagonal, diagonal AC. We define the size of diagonal AC SY, that is to say diagonal DC equals to Y units in size. Then according to rule number 2, the product of its diagonals, the product of the product of quadrilateral ABC diagonals, it is actually x times y, and the product of its diagonals equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is actually side AD is opposite to side BC, and the product of those two opposite sides is B times D. And the second pair of opposite sides of quadrilateral ABCD is side AB is located in the opposite side of side DC, and the product of those two opposite sides, it is actually A times C, and according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD. The second product of its opposite sides is BC. And the sum of the products of its opposite sides is BD plus AC. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. That is actually BD plus AC. Okay, I'll repeat again. If quadrilateral ABCD is inscribed by a circle, this quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is actually BD plus AC. So the product of its diagonals xy equals to the sum of the products of its opposite sides. This is actually BD plus AC. So whenever you have a quadrilateral that is inscribed by a circle like in this drawing, then the product of the quadrilateral diagonals, that is actually x times y, will be equal to the sum of the products of its opposite sides. This is actually BD plus AC. Okay, this is actually the meaning of rule number 2. Okay, and we also have rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. I will read rule number 3 again. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have this circle and inside this circle we have a triangle ABC that it is inscribed by this blue circle, so this is triangle ABC. And we know that side AB of triangle ABC equals to A unit in its size, side BC of triangle ABC equals to B unit in its size, and side AC of triangle ABC equals to C unit in its size. Then, according to rule number 3, if triangle ABC is inscribed by a circle, this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, then the radius of that circle, so the radius of this blue circle that blocks triangle ABC, the radius of the circle equals to the product of triangle ABC sides. So the radius of this circle equals to the product of triangle ABC sides, and the product of triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, so according to rule number 3, whenever you have a triangle that is inscribed by a circle, then the radius of that triangle that blocks, the radius of that circle that blocks the triangle will be equal to the product of its sides. In this case, it is A times B times C over 4 times the area of that triangle that is described by the circle here over 4 times the area of triangle ABC that is inscribed by this blue circle. Okay? Okay? So if we have a triangle ABC that could be any triangle that is inscribed by a circle, then the radius of the circle that blocks the triangle will be equal to the product of its sides. In this case is A times B times C over 4 times the area of the triangle that is blocked by the circle here. Triangle ABC is blocked by this blue circle, therefore it is 4 times the area of triangle ABC that is inscribed by this blue circle. So R equals to ABC over 4 times the area of triangle ABC. That is rule number 3. So we'll actually implement all 3 rules in our drawing. So we have rule number 1. According to rule number 1, if we have quadrilateral ABCD, that could be any quadrilateral, then the area, if we have quadrilateral ABCD that is inscribed by a circle, then the area of this quadrilateral will be equal, according to rule number 1, the area of quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D. So the area of a quadrilateral that is inscribed by a circle will be equal to this expression when A, B, C, and D are the lengths of the quadrilateral sides, and S equals to A plus B plus C plus D over 2. Okay, that is the implementation of rule number 1 in our drawing, and we'll implement also rule number 2 in our drawing. According to rule number 2, if we have quadrilateral ABCD that is inscribed by a circle, like in this drawing, then the product of its diagonals, quadrilateral ABCD has 2 diagonals, diagonal DB. We define the size of diagonal DB or BD as x, so diagonal BD equals to x units in size, and the second diagonal AC is defined as y, that is to say it equals to y units in its size. Then according to rule number 2, the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. Okay? So, I'll repeat again. If we have a quadrilateral ABCD that is inscribed by this blue circle, then the product of the quadrilateral diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is actually BD plus AC. So the product of its diagonals is x times y, and it will be equal to the sum of the products of its opposite sides, that is actually BD plus AC. Okay, so we will implement also rule number 3 in our drawing, and we relate to triangle ABC. Triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say to A times B times Y, over 4 times the area of triangle ABC. I repeat again, here we have triangle ABC that is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of triangle ABC. Okay, here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABY over 4. Okay, here we will divide equation number 3 by R, and we will get the area of triangle ABC. We get that the area of triangle ABC according to equation number 3 equals to ABY over 4R. We divided equation number 3 by R, and we got that the area of triangle ABC equals to ABY over 4R. Okay, so in the next step we will focus on this triangle ADC. As you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of triangles ADC sides, that is to say C times D times Y, over 4 times the area of triangle ADC. So I will repeat again. Actually, we focus on triangle ADC. Triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times Y over 4 times the area of triangle ADC. This is according to rule number 3. We will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDY over 4. So here we will divide equation number 4 by R, and we will get that the area of triangle ADC equals to CDY over 4R. Okay, so we actually found out the areas of triangle ABC and also the area of triangle ADC. But as you can see from the drawing, if we combine together the area of triangle ABC with the area of triangle ADC, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. I will write it down. the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Okay? So according to question number 1, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Okay? So the area of quadrilateral ABCD according to question number 1 equals to the area of triangle ABC, but we already found out that the area of triangle ABC equals to ABY over 4R. Plus the area of triangle ADC, but we have already found out that the area of triangle ADC equals to CDY over 4R. So here we'll take the common factor y over 4R out of these expressions, and we will get that the area of quadrilateral ABCD, according to question number 1, equals to, so y over 4R is a common factor. Inside inside the brackets we will have here AB, and from this expression what is left after we took y over 4R as a common factor, what is left is actually CD. So we actually found out that according to equation number 1, the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Okay? So in the next step we will focus on this triangle, triangle BDC. So this triangle, triangle BDC, is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that is this blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of triangle BDC. I'll repeat again, triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the area of this blue circle, capital R, will be equal to the product of triangle BDC sides. The product of triangle BDC sides is B times C times X over 4 times the area of triangle BDC. 4 times the area of triangle BDC. Here we will multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCX over 4. So here we will divide equation number 5 by R in order to get the area of triangle BDC. And we will get that the area of triangle BDC according to equation number 5 equals to BCX over 4R. So we actually found out the area of triangle BDC equals to BCX over 4R. So in the next step we will focus on triangle ABD. As you can see from the drawing, this triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD. I repeat again, triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of the blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD. So we will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to ADX over 4R. So we found out the area of we will okay. We multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADX over 4. Here we will divide equation number 6 by R, and we will get the area of triangle ABD. So the area of triangle ABD will be equal to ADX over 4R. So we found out the area of triangle ABD, according to equation number 6, it equals to ADX over 4R. Okay, so we found out the areas of triangle ABD and triangle BDC. Okay, but as you can see from the drawing, if we combine together triangle ABD with triangle BDC, we will get the quadrilateral ABCD. Okay, quadrilateral ABD plus quadrilateral BDC gives us triangle ABD plus triangle BDC gives us quadrilateral ABCD. So I will write it down. According to question number 2, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. It's very easy to see it from the drawing. So we found out that the area of quadrilateral ABCD, according to equation number 2, equals to the area of triangle ABD plus the area of triangle BDC. Okay, so we actually found out that the area of quadrilateral ABCD, according to equation number 2, equals to the area of triangle ABD, but we have already found out that the area of triangle ABD equals to A dx over 4R plus the area of triangle BDC. We have already found out that the area of triangle BDC equals to BCX over 4R. Okay, so here we will take a common factor of x over 4R out of these two expressions, and we will get that the area of quadrilateral ABCD according to equation number 2 equals to x over 4R, and inside the brackets here we will have AD, and what is left from these expressions after we took x over 4R as a common factor, what is left is actually BC. So we actually found out that according to equation number 2, the area of quadrilateral ABCD equals to x over 4R times AD plus BC. But we have already found out that the area of quadrilateral ABCD according to equation number 1 equals to y over 4R times AB plus CD. So we actually have two different expressions for the area of quadrilateral ABCD. So we will multiply equation number 1 by equation number 2, and we will get that the area of quadrilateral ABCD squared, we will get equation number 3 that states that the area of quadrilateral ABCD squared equals to x times y over 4R squared times AD plus BC times AB plus CD. So here we will take a root out of this equation number 3, and we will get that the area of quadrilateral ABCD according to equation number 3 equals to the root of the expression in the numerator. It is actually the root of x times y AD plus BC times AB plus CD and the root of the denominator 4R squared is 4R, because the root cancels the square and what is left only 4R. Okay, so we actually found out that the area of quadrilateral ABCD according to equation number 3 equals to this expression. Here we will multiply equation number 3 by R, and then we will divide it by the area of quadrilateral ABCD. So first of all we will multiply equation number 3 by R, and we will get that R times the area of quadrilateral ABCD equals to the root of x times y AD plus BC times AB plus CD. Over 4. So now we will divide the equation number 3 by the area of quadrilateral ABCD, and we will get the radius of the circle that we are looking for. Okay, we will get that actually the radius of the circle that we are looking for equals to the root of xy, x times y, times AD plus BC, times AB plus CD, over 4 times the area of quadrilateral ABCD. So here we have the expression of x times y inside the root of equation number 3 here. But we know that according to rule number 2, x times, according to rule number 2, x times y equals to AC plus BD. Okay, x times y equals to AC plus BD according to rule number 2. Therefore, we can substitute xy in equation number 3 by AC plus BD. So we'll do it now, and we will get that the radius of the circle that we are looking for will be equal to the root of xy, and xy equals to AC plus BD. We substitute xy by AC plus BD times AD plus BC times AB plus CD, all divided by 4 times the area of quadrilateral ABCD. So here we have all the values of all the variables here, ABCD, and the only thing that is left to do is to find out the area of quadrilateral ABCD. We actually found out the area of quadrilateral ABCD, so I will repeat again. The area of quadrilateral ABCD according to rule number 1 equals to the root of S minus A times S minus B times S minus C times S minus D. And S equals to A plus B plus C plus D over 2. According to rule number 1, so the area of quadrilateral ABCD equals to this expression according to rule number 1, and S equals to A plus B plus C plus D over 2. So I will write down the values of A, B, C, and D, and we will put the data inside these two equations in order to find out the value of S and the area of quadrilateral ABCD. We know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So we get that S equals to A plus B plus C plus D is 3, A is 3, B is 4, C is 5, and D is 6 over 2. So 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18, and 18 over 2 is 9. So we found out that S equals to 9. So we'll substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD equals to the root of s minus a. S is 9 and a is 3, so it is 9 minus 3 times s minus b. S is 9 and b is 4, so it is 9 minus 4. S minus c. S is 9 and c is 5, so it is 9 minus 5. S minus d. S is 9 and d is 6, so it is 9 minus 6. So in total we got that the area of quadrilateral ABCD, according to this equality, equals to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So in total we got that the area of quadrilateral ABCD equals to the root of 6 times 5 times 4 times 3. So the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So we actually can substitute the area of quadrilateral ABCD in equation number 3 by the root of 360 that we found here. So we'll do it now. We will get that the radius of the circle that we are looking for equals to AC plus BD times AD plus BC times AB plus CD over the area of quadrilateral ABCD is the root of 360, all divided by 4. Okay, so here I will write down the values of A, B, C, and D, and we will put the data inside this equation number 3 in order to find out the radius of the circle that we are looking for. We know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So we get that the radius of the circle that we are looking for equals to the root of AC. A equals to 3, C equals to 5, so 3 times 5 is 15, plus BD. B is 4, D is 6, so 4 times 6 is 24, times AD. A is 3, D is 6, so 3 times 6 is 18, plus BC. B is 4, C is 5, so 4 times 5 is 20, times AB. A is 3, B is 4, so 3 times 4 is 12, plus CD. C is 5, D is 6, so 5 times 6 is 30, all divided by 360, and we divide it by 4. So we got that, according to equation number 3, the radius of the circle that we are looking for equals to the root of 15 plus 24 is 39, 18 plus 20 is 38, and 12 plus 30 is 42 over 360 all divided by 4. So the area of the circle that we are looking for R equals to this expression. So here we have 39 times 38 times 42 over 360 equals to 172.9. So I will write it down. So we found out that the radius of the circle that we are looking for equals to root of 172.9 over 4 units. So the radius of this circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle will be equal to 3.287 units. So I will repeat again, the radius of this circle equals to either to the root of 172 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Inside this circle we have quadrilateral ABCD, and we know that in quadrilateral ABCD, AB equals to 3 units, so we defined AB as A, and so A will be equal to 3 units. And we also know that BC equals to 4 units, so we define BC as B, and B will be equal to 4 units. And we also know that DC equals to 5 units, so we define DC as C, and C will be equal to 5 units. And we also know that AD equals to 6 units, so we define AD as D, and D will be equal to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. So I presented to you 3 new rules, and we implemented those 3 new rules in our drawing. We have rule number 1. According to rule number 1, the area of quadrilateral ABCD that is inscribed by circle equals to, this is the sign of area, equals to the root of S minus A times S minus B times S minus C times S minus D. When A, B, C, and D are the legs of the quadrilateral ABCD, and S equals to A plus B plus C plus D over 2. Okay, so according to rule number 1, if you have quadrilateral ABCD that could be any quadrilateral that it is inscribed by this blue circle, then you can calculate the area of quadrilateral ABCD according to this formula. The area of quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. Okay, this was a question, rule number 1. And I also presented to you rule number 2. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So if we have this quadrilateral ABCD, and quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. So according to rule number 2, the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, that is to say will be equal to BD plus AC. Okay, so if we have quadrilateral ABCD that is inscribed by a circle, then the products of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say it will be equal to BD plus AC. Okay, that is rule number 2. And I also presented to you rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So, what is the meaning of rule number 3? The meaning of rule number 3 is that if you have a triangle by ABC, that could be any triangle, and triangle ABC is inscribed by this blue circle, then according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times C over 4 times the area of triangle ABC. So whenever you have triangle that is inscribed by a circle, then you can find out the radius of the circle that blocks that triangle according to this formula, that capital R will be equal to ABC, that is the product of the triangle's sides, over 4 times the area of the triangle that it is inscribed by that circle. So R equals to ABC over 4 times the area of triangle ABC. Okay, so this is rule number 3. And we actually implemented rule number 3 in our drawing. We implemented all the rules in our drawing. According to rule number 1, the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Then I presented to you rule number 2, and we will implement rule number 2 in our drawing. According to rule number 2, if we have a quadrilateral that is inscribed by a circle, then the products of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. So x times y equals to BD plus AC. Then I presented to you rule number 3. We will implement rule number 3 in our drawing. If we relate to triangle ABC is inscribed by this blue circle, therefore the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y. The radius of the circle that blocks triangle ABC will be equal to the product of its sides, that is to say A times B times Y over 4 times the area of triangle ABC. That is according to rule number 3. Here we multiply the equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABY over 4. So here we divide the equation number 3 by R, and we got that the radius, the area of triangle ABC equals to ABY over 4R. Then we focused on triangle ADC. We focused on triangle ADC. As you can see from the drawing, this triangle ADC, is described by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangles ADC sides. That is to say, it will be equal to C times D times Y. It will be equal to C times D times Y over 4 times the area of triangle ADC. Okay, so here we multiplied equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDY over 4. We divided equation number 4 here by R, and we got that the area of triangle ADC equals to CDY over 4R. So we found out the areas of triangle ABC and the area of triangle the area of triangle ADC and the area of triangle ABC. But as you can see from the drawing, the area of triangle ABC plus the area of triangle ADC gives us the area of quadrilateral ABCD. So we can write down that the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. But we have already found out that the area of triangle ABC equals to ABY over 4R, and the area of triangle ADC equals to CDY over 4R. Here we took a common factor of y over 4R of these expressions, and we got that the area of triangle of quadrilateral ABC equals to y over 4R, and inside the brackets we have AD plus CB, or AB plus CD. Okay, then so the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Then we focused on triangle BDC. And triangle BDC, actually triangle BDC is inscribed by this blue circle. Therefore, the radius of this blue circle that blocks triangle BDC, this triangle BDC, equals to the product of triangle BDC sides. That is to say, it equals to B times C times X, B times C times X over 4 times the area of triangle BDC. This is according to rule number 3. We multiplied the equation number 5 by the area of triangle BDC, and we got that R times the area of triangle BDC equals to BCX over 4. Here we divided the equation number 5 by R, and we got that the area of triangle BDC equals to BCX over 4R. Then we focused on triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangle ABD sides. That is to say, it will be equal to A times D times X, A times D times X, over 4 times the area of triangle ABD. Okay, over 4 times the area of triangle ABD. This is according to rule number 3. Here we multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADX over 4. Then we divided the equation number 6 by R, and we got that the area of triangle ABD equals to ADX over 4R. And we have already found out that the area of triangle BDC equals to BCX over 4R. Okay? But what is, if we combine triangle BDC with triangle ABD, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABD plus the area of triangle BDC. But we have already found out that the area of triangle ABD equals to ADX over 4r, and we have already found out that the area of triangle BDC equals to BCX over 4r. So the area of quadrilateral ABCD will be equal to this expression. Here we took a common factor of x over 4r out of this expression, and we got that the area of quadrilateral ABCD equals to x over 4r, and inside the brackets what is left is AD plus BC. This is the area of quadrilateral ABCD according to equation number 2, but we have already found out that the area of quadrilateral ABCD according to equation number 1 equals to y over 4r times AB plus CD. So we multiplied the equation number 2 by equation number 1, and we got that the area of triangle ABCD squared equals to this expression. Then we took out the root out of equation number 3, and we got that the radius, that the area of quadrilateral ABCD equals to the root of this expression in the numerator, and the root of 4r squared equals to 4r. Okay, here we multiplied the equation number 3 by r, and we got that r times the area of quadrilateral ABCD equals to the root of this expression over 4. Then we divided the equation number 3 by the area of quadrilateral ABCD, and we got that the radius of the circle that we are looking for equals to this expression, and we have x times y in this expression, but according to equation rule number 2, x times y equals to AC plus BD, so we can substitute xy in this equation number 3 by AC plus BD that equals to xy. So we substituted xy in this equation number 3 by AC plus BD, and we got this expression. So we have the values of A, B, C, and D. The only thing that is left to find is to find out the area of quadrilateral ABCD. And we have already found out the area of quadrilateral ABCD, but I repeat it again on the same thing, that the area of quadrilateral ABCD equals according to equation to rule number 1 to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of quadrilateral ABCD, and s equals to 8 plus b plus c plus d over 2. This is according to rule number 1. So we found out the value of s equals to a plus b plus c plus d over 2, a equals to 3, b equals to 4, c equals to 5, and d equals to 6. So s equals to 3 plus 4 plus 5 plus 6 over 2. 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18, and 18 over 2 is 9. So we found out that s equals to 9, so we can substitute s in this equality by 9. And we get that the area of quadrilateral ABCD equals to the root of s is 9 minus a is 3, so it is 9 minus 3, s minus b, s is 9 and b is 4, so s minus b is 9 minus 4, and we have s minus c, s is 9 and c is 5, so s minus c is 9 minus 5, and we have also inside the root s minus d, and s is 9 and d is 6, so s minus d is 9 minus 6. So in total we got this expression, and we know that 9 minus 3 is 6, 9 minus 5, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So we found out that the area of quadrilateral ABCD equals to the root of 6 times 5 times 4 times 3, and 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Then we substituted the area of quadrilateral ABCD in equation number 3 by the root of 360 square units, because the area of quadrilateral ABCD equals to the root of 360 square units. So we substituted it by the root of 360 square units, and we got this expression. Then we found out the values of those expressions. A equals to 3, C equals to 5, so 3 times 5 is 15, B equals to 4, D equals to 6, so 4 times 6 is 24, A equals to 3, D equals to 6, so 3 times 6 is 18, and we have BC, B equals to 4, C equals to 5, so 5 times 4 is 20, and we have AB, A is 3, B is 4, so 3 times 4 is 18, and we have also CD inside this root. C is 5, D is 6, so 5 times 6 is 30. So here we have R equals to this expression, and here 15 plus 24 is 39, 18 plus 20 is 38, and 20 plus 12 plus 30 is 42. So in total we got that the radius of the circle equals to the root of 49 times 30, to the root of 39 times 38 times 30 times 42 over 360, and the value of this expression inside the root in total equals to 172.9, because 39 times 38 times 42 over 360 equals to 172.9, and all divided by again I will repeat, 39 times 38 times 42 over 360 equals to 178.9, and all is divided by 4. So we found out that the radius of the circle, the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 302.87 units. I will repeat again, the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.